Welcome to Maths for You channel. Another past question, a part of past question on combination and permutation. Let P1 and P2 be the two sets given by A, B, C, D, E, 1, 2, 3, 4, one set, F, G, H, I, J, 5, 6, 7, 8, another set, respectively. It is required to form a password consisting of 6 elements taken from P1 and P2, of which 3 are different letters and 3 are different digits. In each of the following cases, find the number of different such passwords that can be formed. Question 1. All 6 elements are chosen from P1. Second one, 3 elements are chosen from P1 and 3 from P2. Let's look at it, and let me write that. P1 is A, B, C, D, E, 1, 2, 3, 4, 5 letters and 4 digits. P2, F, G, H, I, J, 5, 6, 7, 8. Again, 5 letters, 4 digits. The password we'll have to form with 6 elements. It's in that element 3 letters and 3 digits. So any 3 letters, any 3 digits have to form 6 elements, and with that 6 elements, then we need to form a password. Let's look at the first question 1. All 6 elements from P1. So P1, we have 5 letters and 4 digits. So we need to select 3 letters, 3 digits, because of that the password require 3 letters and 3 digits. So 5 letters, we need to choose any 3 letters out of 5. So that is combination. 5 out of 3, combination. Selecting or picking 3 from 5 is a combination. Therefore, 3 letters out of 5 is 5C3, the combination, because of picking 3 out of 5, any 3. Again, picking any 3 digits out of 4 digits, therefore combination 4C3. So these are the 2 combinations. Having picked every time having picked 3 letters and 3 digits, form 6 elements. Then out of 6 elements, we have to form, or we have to arrange a password. So all 6 elements used to arrange a password. So again, arrange a password, so permutation, but we are using all 6 elements. Therefore, the number of permutation we can get factorial 6 factorial. Right, let's do it. Number of passwords we can do it. Then we know the combination, the letter combination 5C3, time the digit combination 4C3, then times having picked up all 3 letters and 3 digits, and then 6 element form such a way, and how many time is 6 factorial. So 5C3 times 4C3 times 6 factorial is the number of password can be formed with 3 letters and 3 digits randomly picked from P1. So 5C3, 5 factorial divided by 3 factorial, 2 factorial times 4C3, 4 factorial divided by 3 factorial, 1 factorial times 6 factorial. So 5 factorial can be written as 5 times 4 times 3 factorial, and the denominator 3 factorial, 2 factorial, 3 factorial cancel. Then 4 factorial can be written as 4 times 3 factorial, and the denominator 3 factorial, 1 factorial. Again, 3 factorial cancel out. So what we left with, 5 times 4 divided by 2. 5 times 4 is 20 divided by 2. So that is divided by 2. Then 4 divided by 1 and 6. So this is, if I could write again, as 10 times 4 times 6 factorial. I'm not going to work out in numbers, so it's just simply 40 times 6 factorial. 6 factorial straight from the calculator, so I'll leave it there. Let's look at the second question. Second question says 3 elements, it doesn't say the 3 letters or digits, 3 elements. It could be letters and digits, any combination. So 3 elements from P1 and 3 elements from P2. So we have 5 letters and 4 digits. So out of 3 elements, so we can make number of way to pick three elements from P1, 3 elements from P2. So first one, say we pick up all 3 letters from P1. So that's a possibility. You're picking up all 4 letters, all 3 letters from P1. If that's so, we need to pick up 3 digits. Of course, 3 digits. We need 3 digits to form a password. 3 letters, 3 digits. Next combination, 2 letters from 2 letters and 1 digit from P1. If that's so, 1 letter and 2 digits from P2. Then third one, 1 letter and 2 digit from P1. If that's so, 2 letters and 1 digit from P2. And 0 letters, so no letters at all. So 3 digits from P1 and P2, of course, 3 letters and no digits. So these are the 4 type we can come up with. So let's look at the combination of the first one. So we are taking 3 letters out of 5 letters. So the combination of that, 5C3. And then again, we are taking 3 digits we need. So we are taking 3 digits out of 4 digits. Therefore, the combination of that is 4C3. So the first one, the letter combination is 5C3. The digit combination of P2 is 4C3. And the second combination, we are taking 2 letters from out of 5 and taking 1 digit out of 4. So 5C2 times 4C1. If that's so, we are taking only 1 letter from P2. So 5C1 times 4C2 is 2 digits. And the third one, we are taking 1 letter from P1, but 2 digits from P1. So 5C1, 1 letter, 4C2, 2 digits, and P2, if 2 letters we have to say, 5C2 times 4C1, because of 1 digit from 4 digits. The fourth one, all letters, digits, 4C3 from P1, digits, 3 digits, so 4C3. And P2, we are taking letters only, 5C3. So these 4. Let's look at one by one. Every time we are selecting 6 elements. So the first combination is 6 elements. Out of 6 elements, we are using all 6 elements to form a password. Therefore, that the number of password from first type, 5C3 times 4C3 times 6 factorial. That the second one will be 5C2 times 4C1 times 5C1 times 4C2, because of just 2 letters, 1 digit, 1 letter, 2 digit, and again 6 elements being used, so 6 factorial. And the third type, 1 letter 5C1, 2 digit 4C2 times 2 letter 5C2 times 1 digit 4C1. Again 6 element. The permutation is factorial, 6 factorial. And again, now fourth type, 3 digits, 4C3, and 3 letters, 5C3 from P2. And again, 6 elements formed or arranged to get a password. Therefore, permutation is 6 factorial. So, right, okay, that's 1. 5 factorial over 3 factorial 2 factorial times 4 factorial over 3 factorial 1 factorial times 6 factorial. So this is 5 times 4 times 3 factorial, 3 factorial cancelled out. And then 4 times 4, 20, divided by 2 is 10, like first one. And this one is 4, 4 factorial over 3 factorial times 1 factorial, 4, and 6. So 10 times 4 times 6 factorial, the first one. Second one, 3 factorial and 2 factorial for 3 factorial, 5 factorial divided by 2 factorial, 3 factorial, and 4 factorial over 1 factorial, 3 factorial, 5 factorial, 1 factorial, 4 factorial, 4 factorial over 2 factorial, 2 factorial. So if you could work out, the first one is 10, so 5 times 4 factorial 3, 3 cancel out, 2 divided by 20 divided by 2 is 10. And then it's 4, and here is 4, so it's just 5. And this one's 4 times 3 times 2 factorial, 2 factorial, 2 factorial, cancel all. 4 times 3 is 12, 12 divided by 2 is 6. So 10 times 4 times 5 times 6 times 6 factorial. That is second type. Third one, 5 factorial over 5 factorial, 1 factorial, 4 factorial, 4 factorial over 2 factorial, 2 factorial, 5 factorial over 2 factorial, 3 factorial, 4 factorial over 1 factorial, 3 factorial times 6 factorial. We have seen this before. The first one is 5 because of which is on the second part with this type there. Second one is 6. Third one is 10. Fourth one is 4 and 6 factorial. So 5 times 6 times 10 times 4 times 6 times 4, 6 factorial. And the last one, 4 factorial over 3 factorial times 5 factorial or 2 factorial, 3 factorial, 2 factorial times the permutation is 6 factorial. So 4 factorial, 3 factorial is 4, 5 factorial, 3 factorial, 2 factorial is 10, and 6 factorial. So these are many times because so the part 2 is huge amount of passwords we can make. Yeah, that's about it. So just selecting number of items out of many items is a combination, and then again getting that the picked up items or elements and arranging it in such a way, randomly arranging it, and that is permutation. And if you use all of them, that's just that number factorial. And if it's not, as different anyway. There's nothing to discussion. Thank you. Please subscribe to the channel and share these contents with your friends, please. Thank you.